I am an avatar organized by Dr. Alemi to present this lecture on how to estimate joint distribution from regressions, the same regression used to create the network structure. This table shows key findings from a chain of 5 regressions. Previously, we used these regressions to construct the network structure. Our analysis led to this network. This describes the structure of the network. We now show how the same regressions that brought us to this structure also lead us to the discovery of the underlying joint distribution of the variables. Each regression represents a table within the network. Let's start with the regression of y on prior events. First, we create a factorial combination of direct predictors of y. To generate the factorial combination of 4 variables, we will need a table that has 2 to the power of 4 rows. That is 16 rows. In half of the 16 rows, covariate C1 is present and in half it is absent. Covariate C2 is present in half of the times when covariate C1 is present and absent in the rest. Similarly, covariate C2 is present in half of the times when covariate C1 is absent and C2 is absent in the rest. The same procedure is followed for exposure variable, where C1 is present and C2 is present. Also when C1 is present but C2 is absent, and so on until all combination of C1 and C2 and exposure are marked. The procedure is continued for all variables until a factorial combination is created. The first row shows the combination where all 4 predictors are present. The fourth row shows situations where the 2 covariates are present, but exposure and mediator are absent. The last row shows the situation where none of the predictors are present. The regression equation is used to calculate the probability of y. In logistic regression, this is done as 1 divided by e to the inverse power of the regression equation. The intercept is 0.3. The coefficient for C1 is 0.12. C1 is present, then it has the value of 1. The coefficient for C2 is 0.22. C2 is present and has the value of 1. The regression is evaluated for all the values in the row, yielding a probability of 0.77. The regression equation provides the joint distribution of y for different values of covariates, exposure, and mediator variables. The regression equation for exposure x is used to calculate the probability of the exposure variable x. When both covariates are present, the conditional probability is 0.79. The conditional probability of exposure given presence of C1 but absence of C2 is 73%. Similarly, evaluating the regression equation for each row gives us the values of 62% and 53%. This completes the joint distribution of exposure variable x. The regression equation for covariate C1 has no direct predictor. Just the intercept is used. The regression equation is also used to calculate the probability of the occurrence of covariate C2. When x is present, this probability is of the mediator z is 0.78. When x is absent, the probability is 61%. This completes the specification of the joint distribution of the mediator variable. We have learned both the structure and parameters of the network from its associated regressions.